All right, today we'll be factoring by grouping. We have learned to factor by the greatest common factor. We have learned how to factor difference of squares. And now we're going to learn how to factor by grouping. The only time I can use this method that I'm about to teach you is if it is a 4-term polynomial, meaning I have 4 terms. If I try to list the greatest common factors between all 4 of these terms, x squared, 5 and x, 3 and x, and 15. I don't have a greatest common factor that is in common for all of them except for 1. So basically, I don't have a greatest common factor, but I can still factor this. I can factor it by grouping my 4-term polynomial into 2 binomials, simply by putting a parentheses around the first 2 terms and a parentheses around the second 2 terms, making me have 2 binomials. I can factor out the greatest common factor for each of my binomials, finding the greatest common factor for x squared and 5x, and finding the greatest common factor for positive 3x and positive 15. So the greatest common factor for x squared plus 5x. Well, if I look at x squared and 5x, they don't share any coefficients, but they do share one variable. That means I can factor out an x. Well, if I factor out an x, what does it leave me behind? So if I start off with 2 x's and I factor out an x from each term, well, this x cancels, and what am I left with? X. This x cancels, what am I left with? Positive 5. Then I need to find the greatest common factor of my second binomial, which is positive 3x and positive 15. Well, they each share a 3, and they don't share any variables. Therefore, I can factor out a positive 3. When I factor out a positive 3, what is left behind? Well, 3's cancel, and I'm left with x. 15 divided by 3 is 5. If you notice, in the middle, I have twins, x plus 5 and x plus 5. I call them twin because they're the same. This twin is my common factor. So my twin, aka my common factor, gets a binomial, and what is left over gets the other binomial. So this is the factored form of x squared plus 5x plus 3x plus 15. Do a couple more examples. All right, 6xy minus 8x plus 15y minus 20. So I ask myself, do any of these terms have a greatest common factor? 6xy, 1 and 6, 2 and 3. Negative 8x, 1 and 8, and 2 and 4. 15y, 1 and 15, and 3 and 5, and 20. 1 and 20, 2 and 10, and 4 and 5. Do they all share a number that is common for all? No, they don't all share a variable either. So I can group my 4-term polynomial into 2 binomials. And I can find the GCF of my first set, and I can find the GCF of my second set. So 6xy minus 8x. What is my greatest common factor? Well, 6 and 8 share 2, and they also share 1x. So I can factor out 2x. Well, when I factor out 2x, what does it leave behind? Remembering that factor out just means divide. So 6 divided by 2 is 3. These x's cancel, and I'm left with y. Negative 8 divided by 2 is negative 4. and these x's cancel out. So that's it. Well, what about 15y minus 20? Well, what is the greatest common factor between these terms? 5. They don't share any y, so I can't factor it out. So I can factor out a positive 5. Well, when I factor out a positive 5, what does it leave behind? 15y divided by 5 is 3. And negative 20 divided by 5 is a negative 4. And if you notice, I have a twin, aka a common factor. So my common factor gets a binomial, and what is left over gets a binomial. All right, 2x cubed minus 3x squared minus 2x minus 1. Do they all share a common factor? So 2x cubed, 3x squared, 2x, and 1. So 1 and 2 with 3 x's, 1 and 3 with 2 x's, 1 and 2 with 1 x, and just 1. So the greatest common factor that they all share is 1. Therefore, I need to group this into 2 binomials. Well, my greatest common factor between 2x cubed and negative 3x squared is 2 x's. Therefore, I can factor out x squared. So when I factor out x squared from 2x cubed minus 3x squared, what do I get? And I factor out 2 x's, remembering that it means to divide. Cancel, 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 cancel. I'm left with 2x. Cancel, 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 cancel. I'm left with negative 3. Bring down my minus sign. Greatest common factor between 2x and a negative 1. Well, it looks like it's just 1. So I need to factor it out. Well, when I factor out that 1, what does it leave? The same thing, 2x minus 1. The question is, do I have a set of twins? I don't. I have no common factor because these are not the same. Therefore, it's not factorable. And we call that prime. All right, any other questions? Feel free to ask me in class.